Hi Trigoners, these are notes for R3 and we are going to be discussing polynomials. Go ahead and read the objectives. We're going to be able to determine if an expression is a polynomial, be able to add, subtract, and multiply polynomials, be able to factor polynomials. Well, polynomials are expressions that are built from constants and variables using only addition, subtraction, multiplication, and raising to natural number powers. Polynomials can be classified according to their degree. The degree of the term is the sum of the powers of the variables. The degree of the polynomial is the degree of the non-zero term with the highest degree in the polynomial. Any non-zero constant is defined to be a polynomial of degree 0. The number of 0 is actually also a polynomial, but it is not assigned a degree. So let's go ahead and look at the first part. We're going to be looking at number 1, find the degree of the polynomial. So go ahead and using what was in the written in the paragraph, see if you could find the degree of each polynomial. Pause the video and give it a try. So did you realize that for 1a, the degree was 3? Because the degree of this term, the first term is 2, the second term is 3, and this is a constant. So the degree is 0, and this is a degree of 1. So the term with the highest degree in the polynomial is 3. So the degree of the entire polynomial is 3. Over here, you had to add the 2 and the 3 because the degree of the first term is 5. Because we're looking at the powers of the variables. The degree of the second term is 4. So the degree of the entire polynomial is 5. Well, now that we know how to find the degree of a polynomial, we should probably discuss how do we even know if something is a polynomial. So again, in the paragraph above, they were warning you to, it's not a polynomial if you have a fractional exponent on a variable. So again, not a polynomial if we have variables with fractional exponents, variables with negative exponents, variables with absolute value of a variable. That's not a polynomial because that's an operation that is not addition, subtraction, multiplication. So go ahead and pause the video and decide for part 2 which of those expressions are polynomials. Give it a try. Pause the video and give it a try, please. All right, so go ahead and take a look at the answers. A couple of things that might be slightly confusing. Notice number A was pretty straightforward because we have a negative exponent, which is division by a variable. Over here, there was an absolute value, but that's fine because that's an absolute value of a number. The absolute value of 3 is 3. It's not the absolute value of a variable. Over here, that would be a negative exponent. Over here, we have absolute value of a variable, so we're not going to have, that's not going to be a polynomial. This is a variable with a fractional exponent. That's actually the 1/2. Notice f is fine because you can have the square root of 7. You could have a fractional exponent for a plain old number, and then no for g because that's a fractional exponent of a variable. And now that we know what a polynomial is and how to find its degree, why don't we talk about simplifying like terms. Two terms in a polynomial are like terms if they have exactly the same variable factors to the same powers. So like the terms in a polynomial are combined, or sorry, like terms in a polynomial are combined by adding their numerical coefficients. So for A, notice we have 3x squared and 5x squared and negative x squared. So we can add those. Those are like terms. So you end up with 7x squared minus 2x. Go ahead and pause the video and try part B. Okay, so for the first step, hopefully you distributed the negative 2. Now, inside these parentheses, we could distribute a negative sign. So what we're going to do is we can combine 3x and 2x if we want. And negative x plus 2 plus 1 is negative x plus 3. So now you're going to distribute a negative 3x. Negative 3x times negative x is positive 3x squared. Negative 3x times 3 is negative 9x. So we combine like terms. The negative 9x and the x are like terms. Okay, so for part 4, now we have addition, subtraction, multiplication, and we would have to combine like terms. So I want you to go ahead and think about 4a and b. They're very different. Notice that 4a means the quantity a times b times the quantity a times b. So that's a squared, b squared, where part b is very different. So go ahead and pause the video and try part b. Part b, you have the quantity a plus b times the quantity a plus b. You need parentheses, so you would have a squared plus ab plus b squared, and you can combine like terms. Notice for part C, you're subtracting, so you can distribute the negative sign. So we have 2 minus 5x minus 4x plus 1. So if you combine like terms, you have 3 minus 9x. Why don't you go ahead and pause the video and try part D. So for part D, we have 2 times 4x is 8x, 2 times negative 1 is negative 2, negative 5x times 4x, and negative 5x times negative 1. So now if I combine like terms, I have negative 20x squared plus 13x minus 2. Okay, so notice for E and F, they're very different. E, you are adding, and for F, you're multiplying. So go ahead and pause the video and try E and F. For part E, you're adding, so you're going to add like terms, negative 5x plus 4x, and add like terms of 2 and negative 1, and you have negative x plus 1. But notice for part F, you have 2 minus 5x, and you have 2 plus 5x. Those are actually called binomial conjugates. So notice that when you multiply 2 times 2, you get 4, and negative 5x times positive 5x is negative 25x squared, but the negative 10x and the positive 10x will cancel. Okay, so for part G, I think it might help your eyes if you actually write it out. It's the quantity 2x plus 1 times the quantity 2x plus 1. So we end up with 4x squared plus 2x, and plus 1. So notice the inside terms do not cancel because we didn't have a plus, even though 2x and 1 were the same terms, just like we had going on up here with the 2 and the 5x. But in F, we had a plus and a minus, and G, we have 2 positive signs. So 4x squared plus 4x plus 1. Okay, so for part H, this might take a while because you have to distribute x times each term in the trinomial. Then you're going to distribute the negative 2. You're going to multiply negative 2 times each term in the trinomial. So go ahead and pause the video and give it a try. So I multiplied x times x squared and got x to the third, x times 2x and got 2x squared, x times 4 and got 4x. I just like to write another line just so it's going to help my eyes later. Negative 2 times x squared, negative 2 times 2x, and negative 2 times 4. Again, the biggest mistake I think people make is, they'll maybe they'll write messy or they'll miss a term. So you really want to go slow and check your work. So we have x cubed minus 8. Okay, now for part I and J are probably a little bit more challenging. Actually, I, J, K, and L. Very easy to make a mistake. You have a trinomial multiplied by a trinomial. So you're going to have to multiply x squared times each term in the trinomial, and then negative x times each term in that second trinomial, and then 2. So go ahead and pause the video, see if you can keep all of your terms organized, and make sure that you don't make a mistake, which might be hard to do on this one. Okay, I like to write a new line. You don't have to do it that way, but it kind of helps me to organize my terms at the end. So I had x squared times each term in the second trinomial. Then I had negative x times each term in the second trinomial, and then 2 times each term. And when I combine like terms, I end up with x to the fourth minus 3x to the third plus 5x squared minus 5x plus 2. Let's try part J. The first thing you want to do is distribute the negative sign. Now I want to show you something kind of clever for this one. If you think of x minus 2 and kind of group it, notice that we have x minus 2 is the first grouping in each set of parentheses, and then we have a plus and a minus, and then a is the same. So if we think of this kind of like multiplying by grouping, so think of this x minus 2 as one term, that might make your job a little easier because minus a times the quantity x minus 2 and positive a times the quantity x minus 2, that's going to cancel out. So we have x minus 2 squared and minus a squared. So that made our job a lot easier for part J. Okay, so for part K, again, there's no shortcut. So this one is, I would say, a challenge problem. We're going to do 2a minus b times the quantity 2a minus b, and a minus 2b times the quantity a minus 2b. And then we'll proceed from there. So go ahead and give it a try. Pause the video and try and go ahead and do 2a minus b times 2a minus b and the quantity a minus 2b squared. So now that we've squared each binomial, we can combine like terms. So, I forgot my square. So we have 4a squared minus 4ab plus b squared minus a squared minus 4ab plus 4b squared. So if you distribute your negative sign, you have 4a squared minus a squared, which is 3a squared. Looking at like terms, minus 4ab minus a minus, which would be plus, so that term cancels out, and b squared minus 4b squared, so that's negative 3b squared. Okay, what if I ask you to cube a binomial? Well, this is going to take a while. So we're going to do 2x plus y, the quantity 2x plus y times the quantity 2x plus y first. So we get 4x squared plus 2xy plus 2xy plus y squared. Combining like terms, that's 4x squared plus 4xy plus y squared. So now you have a trinomial and a binomial. So pause the video and distribute 2x times each term in the trinomial and y. Multiply y by each term in the trinomial. Give it a try. Okay, hopefully you distribute your 2x and your y and you end up with this expression. And so now we're going to look for like terms. I have 8x cubed. And notice the variables have to be the same. So I have 8x squared y and 4x squared y. So that's 12x squared y. I have 2xy squared and 4xy squared. So that's 6xy squared. And we have y cubed. Okay, next, we're going to talk about factoring. A factor of an algebraic expression is one of two or more algebraic expressions whose product is the given algebraic expression. The process of writing an algebraic expression as the product of numbers or algebraic expressions is called factoring. We will assume that we are factoring over the set of real numbers unless otherwise indicated. So when I say factor completely, we are only going to think about real numbers right now. So the first thing you want to do when you're factoring is look for common terms. Notice each of these terms, there are 3 terms for number 5. All of these terms have a common term of 2x and y. So the first thing you would do is factor out the 2xy. So that means that the first term, 2xy times x, y squared, would give you 2x squared, y cubed. And for the second term, you would need a 2x squared y to multiply by 2xy to get negative 4x to the third y squared. And 3 times 2xy is 6xy. So notice we can't factor it anymore. That's it. Why don't you go ahead and pause the video and try number 6. Make sure you factor completely. When we factor, the golden rule of factoring, we always factor out common terms first. It just makes our work easier. So we factor out a 3 because you can. Every term is divisible by 3. And then you factor x squared minus x minus 6. 3 times 2 is 6, and negative 3 plus 2 is negative 1. Okay, so the next thing we're going to do is we're going to look at 7 through 11, and notice 7 through 11, they all have 2 terms. So I kind of organized it this way. If you remember from Algebra 1, if you have a difference of 2 perfect squares, you could say x minus 3 and x plus 3 because the minus 3x and the plus 3x will cancel. So go ahead and think about how you would factor 8, 9, 10, and 11. Go ahead and pause the video and give it a try. They all have 2 terms. Okay, notice for number 8 there is a plus, so that is actually prime because there is no way that you could, for example, if you had x minus 3 times the quantity x minus 3, you would end up with x squared minus 6x plus 9, and if you had a plus and a plus, that would be x squared plus 6x plus 9. There is no way to factor x squared plus 9 with real numbers. Notice for number 9, you could take the square root, right? This is the difference of 2 perfect squares. So you could say x squared y minus 1, x squared y plus 1. The minus and the plus, notice those terms cancel out. Now for number 10, the first thing I would do is factor out the 3, and then notice this problem is very similar to the previous problem. And number 11 is prime because there is a plus sign. Okay, so notice those were we're factoring with 2 terms. So for the next, for the next set of problems here, we are going to focus on problems with 3 terms. So go ahead and pause the video and factor 12 and 13. Number 12, I'm looking for 2 numbers that multiply to give me negative 18 and add to give me negative 7. X minus 9 and x plus 2, that'll do the job. And negative 9x and positive 2x, that's negative 7x. Here's the problem. 13 looks very similar, but we have a y. Notice if you put a y next to your 2 and your 9. Now if we go ahead and check this out, we could do x squared minus 9xy plus 2xy and minus 18y squared. So that will give us the answer. Again, we just put a y in there. So we place the y next to the 9 and next to the 2. For 14 and 15, always look for a common term. So go ahead and see if there's a common term that you can factor out first before you start, or before you factor completely. So for number 14, you could factor out a common term of 2, and then it looks very similar to the problem that we did previously. But for number 15, notice all of the terms do not have a common factor. So this is a little different. When you have a number in front that is not 1, you can't just say, for example, over here we said multiply to give the last number and add to the middle number, because the number 3 in front is it makes everything a little bit different. So we need to multiply two numbers to get 3. So we need 3x and x. And now we still are looking for numbers that multiply to give you -2, but they won't necessarily add to -5. So let's just try, how about a -2 and a 1. So now we have to test it. Go ahead and multiply it out. We have 3x squared plus x minus 6x minus 2. So that's the answer. Go ahead and pause the video and try 16, 17, and 18. 16 was really tricky because when we were looking for numbers that multiply to get 6x squared, you could have used 6 and 1 or 2 and 3. Notice I tried 2 and 3, so if you check this, you have 6x squared minus 9x plus 2x and minus 3. For number 17, we have, maybe the y's were confusing, so maybe it would help if you just pretended the y's weren't there for a minute. And 3x minus 2 and 3x minus 2, that would give me 9x squared minus 12x plus 4, because I knew that 3x times 3x is 9 and 2 times 2 is 4. The only problem is I have y's in there, and that's why I needed to place that y next to the 2, and that is 3x, quantity 3x minus 2y squared. Now for 18, that might be kind of tricky, so it might help if you say something like, let x squared equal a. So you really have a squared minus 4a plus 3. So when you factor, you're looking for numbers that multiply to give you 3 and add to give you -4. But then you realize, oh, x squared, a was really x squared. But you don't want to stop there. Notice you could call this x minus 1 and x plus 1 when you factor x squared minus 1, and x minus root 3 and x plus root 3 if you want to factor x squared minus 3. So the next type of factoring we're going to consider is, some people like to call this factor by grouping. So notice, for example, number 21, we have 4 terms. We haven't talked about that yet. We had 2 terms. We had 3 terms. Over here we have 4 terms, but let's just build up to that. The first thing I want you to do is think about, before we even do number 19, I want you to think about something. Let's say I had x minus 1, the quantity, times the quantity x plus 2. If I were going to expand this, if I were to multiply this, couldn't I do x times x plus 2, and then subtract 1 times x plus 2? Because I could say x times 2, then -1 times x, -1 times 2. So notice if I wanted to go backwards now and factor it, see how I have same, I have an x plus 2? Well, I have x minus 1 of them, right? So I have x of the x plus 2 is minus 1. So notice the x minus 1 is one of my binomials, and then the x plus 2, which was the same, would be our other binomial. So when I look here, I know that x minus 1 is one of my binomials, and 3x minus 2 is the other binomial. So go ahead and pause the video and try number 20. So notice I have the same, right? X plus 5 and x plus 5, so that's one of my binomials. I have 4a squared plus one of them. There you go. Okay, so now for 21, let's say that we're starting at the very beginning. So we're going to kind of group the first 2 terms and the second 2 terms. So notice 3 and a is a common term. And for the second 2 terms, I need the same, right? Just like I had over here, like a same. We had an x minus 1, we had an x plus 5. So I factor out a negative 1. Otherwise, you know, it's not, I'm not going to be able to factor it by grouping, but notice x minus 1, y is one of the terms, and that must be a 1. So 3a minus 1 is my other binomial. Go ahead and pause the video and try number 22. I think number 22 is quite tricky, but notice you're looking for what do they have that's the same. So x minus 1 squared, and then we have 2 times the quantity x minus 1, and then minus 3. So 2x minus 2 minus 3 times the quantity x minus 1 squared. So 2x minus 5 times the quantity x minus 1 squared. Okay, so this is kind of a long lesson, but our last type of factoring is the sum and difference of two cubes. So you're still going to have two terms, but this time it's not going to be the difference of two squares. For example, we had x squared minus 9 earlier, and we said that x squared plus 9 was prime, because if you wanted to factor it, you'd have to say x minus 3i and x plus 3i, and we are using real numbers. So for this one, we have a difference of, oh, that's wrong, sorry about that. I said cubes, but then I wrote squares. So we have to think for the first one, isn't that a cubed, and isn't 1 cubed 1? So the a is going to be my a, and the 1 is going to be my b. So I use this formula, and I would say a minus 1, and then a squared plus 1a plus 1 squared. So that is how you would factor a cubed minus 1. And let's just think about the signs. This might help you. Did you notice that this sign is a negative, and so is this? And then these are positive signs, and this is a positive sign, and so is this. So actually, years ago, a student told me that they think of SOAP, or SOP, I guess, same, opposite, positive. So if we have a negative sign, this is the same. These two signs are opposite, and the back sign is always positive. Go ahead and pause the video and try number 24. So you might say that isn't the sum of two perfect cubes, because 2 is not a perfect cube, but you could factor out the 2. So now I have 2 out in front, and I have a sum of two perfect cubes. So using our formula, we'd say a plus 1, a squared, SOP, right? Same, opposite, positive. So minus a plus 1, because the middle term is a times b. And in this situation, our a was a, right? And I guess that sounds crazy. And then our b was 1. So notice we have a squared minus a plus 1. All right, let's try number 25. 27 and 8, there is not a common term. However, 27 is a perfect cube, and so is 8. So this time, you're going to use 3x as your a and 2 as your b. So pause the video and give it a try. Let's think of famous mistakes. So notice that first of all, same, opposite, positive. Our signs look good. But when you square a squared, notice a had a 3 and an x, so it's 9x squared. So some people make a mistake there. Okay, for number 26, look for common terms. They both have an a and a b. And now let's think about how you would proceed for this one. So, is 9x to the 6 minus y to the 6, is that a difference of two perfect cubes? Actually, 9 is not a perfect cube. However, for this one, since 6 would work for cubes or squares, right? Because x to the third times x to the third is x to the 6, because you add the exponents when you multiply. So and 9 is a perfect square. So this one is not the sum or difference of two perfect cubes. It would be the sum or difference of two perfect squares. You could think of 3x to the third squared and y to the third squared. So pause the video and factor as a difference of two perfect squares. Very good. Okay, so we have two tricky factoring problems. So what I'm going to do is just give you the answer, and I'm going to have you try these on your own. All right, so here are the answers for 27 and 28. Give it a try. And again, these are pretty tricky, so we can always do them in class if you need help. Nice job, everybody.